Yes, good morning everyone. Today we'll be studying the finite state transducers. So what do you mean by finite state transducers? So before understanding what is a finite state transducers, we'll first understand what is a finite state machine. So already we have learned the conversion of DFA to NFA, NFA to epsilon NFA, epsilon NFA to DFA, minimizing of DFA. All this DFA, whatever you have learned, is having a transitions to move from one state to another. And all these state machines, whatever you have learned, are used to recognize the languages. And this is whether transducers, whether it accepts or not, ಅಂತ ಅಷ್ಟೇ ನಾವು finite state machines ಅಂತ ನೋಡ್ತೀವಿ. To accept or not, what type of a language and what are its output ಅಂತ ನಾವು ನೋಡೋಕೆ finite state transducers ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. That is, every state and every transition from one state to another state is associated with the output. So all the, for example, see here, I have state 1 called as Q naught, and upon some input string A, I am moving on to state Q1. Okay, let us think this is one of the sample finite state machine where you are going to accept some language, any language assumption, right? And this particular assumption may accept or may not accept your language, that doesn't matter. But every transition of this machine, that is from Q0 to Q1 upon some input string A, is associated with some output. So conversion of this transition or states from one form to another form which is associated with the output is converted with the help of your transducers, right? These transducers will represent your DFA or DFSM or NFSM, any finite state machines with association with some output values. So upon transition or upon movement of a state and a particular transition, what type of output is associated with the transition anta ನಾವು ಇಲ್ಲಿ ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದು, right? That is how you can define a state transducer is that the process of converting the input data from one form to another form of output is called as transducers. So ಹೇಗೆ ಬರಿಬಹುದು ನಾವು? The process of converting the input form to another form of input string to another form of output is called as transducer. Right? This is what the transducers mean. Transducer means conversion of input string to another form of output is called as transducer. This is a general definition of your transducer. Then what do you understand by finite state transducer? So finite state transducer is a finite state transducer is where output is associated with either transition or every state. every state. So if you are having a DFSM or a FSM, here you are either having an output associated with the states or either associated with the transition. Upon some input symbol, input symbol, the transition is associated with input symbol as well as the output. Or how it is represented on one simple example. Let us take an example of what I'll take Q0 and Q1. So this particular state diagram or finite state diagram represents some particular FSM. Here what will happen is, what we'll consider a condition. So it will print even and odd for even number of ones and even odd number of zeros or even number of zeros and ones even ಅಂತ print ಮಾಡ್ತೀನಿ and odd number of zeros and ones na ನಾನು odd ಅಂತ print ಮಾಡ್ತೀನಿ. For example, this is having alphabet such as 0 and 1 ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ, right? So Q0 upon 1. So one odd number of 1 ಇದೆ. So odd number of 1 ಅಂತ ಇಲ್ಲಿ represent ಮಾಡಿದಾಗ ಇದು odd ಅಂತ represent ಮಾಡ್ತೀನಿ. So ಇಲ್ಲಿದ್ದ 1 ಇಲ್ಲಿದ್ದ ಮತ್ತೆ 1 ಅಂತ ಬಂತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. This transition is having even number of 1. So ಇದಕ್ಕೆ even ಅಂತ represent ಮಾಡ್ತೀನಿ, right? ಅದೇ ತರ 0 odd ಇಲ್ಲೇ ಆಯ್ತು, 0 odd ಆಯ್ತು ಅಂದಾಗ odd ಅಂತ ಕೊಡ್ತೀನಿ. So 0 even ಆಯ್ತು ಅಂತಂದ್ರೆ either 0 like this, 0 or even ನನಗೆ ಇಲ್ಲೇ ತಗೊಂಡು 0 even. A number of zeros odd and even ನಾನು ಇಲ್ಲೇ ತಗೊಂಡಿದ್ದೀನಿ. So ಇಲ್ಲಿ ಕೂಡ ನನಗೆ odd ಆಗಬಹುದು even ಆಗಬಹುದು ಅಲ್ವಾ? So odd even ಹಿಂಗೆ ನೀವು ಕೊಡಬಹುದು, right? ಇಲ್ಲ ಇದು even ಆಗುತ್ತೆ. Odd accept ಮಾಡಲ್ಲ. It won't accept odd. It accepts only even. This accepts odd. ಆ ತರ 1 odd ಆಗಿದ ಮೇಲೆ 0 ಕೂಡ odd ಆಗುತ್ತೆ. So even number of 1. So 1 ಇದೆ, 1 odd. So ಇದು odd ಆಗಿರುತ್ತೆ. So ಅಲ್ಲಿ 1 accept ಮಾಡ್ಕೊಂಡು 0 accept ಮಾಡಿದ್ರೆ ಅದು odd ಆಗುತ್ತೆ, ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. Right? So every transition is ಈ example in detail we will see. So just we are telling that even number of ones ಬಂದಾಗ ವಾಪಸ್ ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಅದು even ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. odd number of first 1 ಬರುತ್ತೆ, ಆಮೇಲೆ 0 ಬರುತ್ತೆ. So zeros ಏನು ಇಲ್ಲ ಅಂದಾಗ even ಇರುತ್ತೆ. 0 ಒಂದೇ ಇದ್ದಾಗ ಅದು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡಲ್ಲ, ಅದು even ಆಗುತ್ತೆ. 0 ಇಲ್ಲಿ odd ಆಗಿರುತ್ತೆ, ಮತ್ತೆ 1 ಬಂದು ವಾಪಸ್ ಇಲ್ಲಿ ಬಂದಾಗ ಅದು even ಆಗಿರುತ್ತೆ, right? So ಈ ಎಲ್ಲಾ ಇನ್ಪುಟ್ ಸ್ಟ್ರಿಂಗ್ಸ್ಗೂ ನನಗೆ even number of zeros and ones ಅಂತ ಬಂದಾಗ ಅದು odd ಮತ್ತೆ even ಅಂತ ನನಗೆ ಔಟ್ಪುಟ್ ಅಸೋಸಿಯೇಟ್ ಆಗಿರುತ್ತೆ. ಈ ತರ ಒಂದು ಸ್ಟೇಟ್ ಡಯಾಗ್ರಾಮ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದನ್ನ ನಾನು ಫೈನೈಟ್ ಸ್ಟೇಟ್ ಟ್ರಾನ್ಸ್ಡ್ಯೂಸರ್ ಅಂತ ಕರಿತೀನಿ, ರೈಟ್? ಇದನ್ನ ಇನ್ ಡೀಟೇಲ್, ದಿಸ್ ಪ್ರೋಗ್ರಾಮ್ ಇನ್ ಡೀಟೇಲ್ ವಿಲ್ ಸಿ. And this particular finite state transducer is categorized into two types. One is Mealy Machine and Mealy Machine. This Mealy Machine is associated with the output associated with the transition, whereas Mealy Machine is output associated with the states, right? So Mealy Machine ಮತ್ತೆ Mealy Machine ಏನ್ ಡಿಫರೆನ್ಸ್ ಇದೆ ಅಂತ ನಾವು ನೋಡ್ತಾ ಹೋಗೋಣ. So now we'll start studying a concept of Mealy Machine. Mealy Machine. So before going to Mealy Machine, now just we'll recall the definition of some DFA. So how is DFA defined? So DFA is defined with 5 different tuples. Can you recognize? One is K. What is K? Next is alphabet. Next is transition function. Next is start state, next is accepting state, right? So can you identify these alphabets? Sorry, these attributes. So K is a finite set of states, finite set of states. This is alphabet set. This is transition function. Start state. Next is accepting state. Next is accepting state. So all these things are the attributes to define your DFA. So your Mealy machine also defines the same attributes. Along with this additional we got two more attributes. So Mealy machine is associated with the output of the. So what are the output alphabets? Output alphabets are. So output alphabets are defined with this symbol. This is output alphabets. Output alphabets. And next is lambda. This is called as output function. So output function is defined using what you call alphabet set into states, alphabet states to output function. This is how your function is defined. Right? This is Mealy machine. So Mealy machine is a machine which represents the output associated with the transition. It's not with the states. Right? So transducers may be output associated with the transition or with a state, but Mealy machine is a proper where you are going to have an association of output only on your transitions. Okay, clear with this? Fine. So now we'll move on to understanding how this particular Mealy machine is designed. Okay, I'll write a question first here. Construct a Mealy machine which accepts a strings of zeros and ones and outputs even when the input string as even number of zeros and ones and odd when the input string has odd number of zeros and ones. Right? So for this thing, what you need to do is, first you need to understand this particular thing. Is it visible? Yes. Okay. First thing what you need to do is, you need to first construct a DFA to analyze. Then you can start to make movements with transition with the association of an output. First, design a DFA to accept a string with even number of zeros and even number of ones. Even and odd number of ones and zeros. So I take a state called, first step, I'll consider a state called Q0, start state, and Q1. So in this you need not represent your final state, because both will be accepting both will be having an output. So whichever is required, that you can make sure. So okay. Hopefully this is a writing DFA which accepts even number of zeros and ones and odd number of zeros and ones accept ಮಾಡತರ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Okay, so let us check with one simple example. So this particular string 110110, this should present you a output, transition of output. So 1, so 1 I accepted, yes, 1. So when 1 is particularly moving from transition from 0 to 1, there is only one single element of a 1, that is 1 is odd. 1 is odd. So this particular 1 can be represented as odd because it accepts only odd, because only there is only one. Next one. So total number of ones will be even. So again it is moving back to Q0 here. So this particular thing can be represented as even, because there is only one, that is odd number. Two number of ones, so it is even. Next is 0. So 0 is 1. Sorry, 0 is 1. So illinda ನನಗೆ 0 odd ಬರುತ್ತೆ, right? So odd ಅಂತ ತಗೊಳ್ತೀನಿ. Next is 1. ಮತ್ತೆ 1 ನನಗೆ 3 ಆಯ್ತು, odd ಅಂತ ಬರುತ್ತೆ. Next ಮತ್ತೆ 1 even ಬಂತು. Next ಮತ್ತೆ ನನಗೆ 0, so ಇಲ್ಲಿ ನನಗೆ even ಅಂತಲೂ ಆಗುತ್ತೆ. Even. So this also can be represented as odd or even, anything, right? ಈ ತರ ನಾನು represent ಮಾಡಬಹುದು. But ಇಲ್ಲಿ even number of 01 01 ಈ ತರ strings ಇದ್ರೆ, ಅಂದ್ರೆ your string is followed by 1 followed by 0 continue ಈ ತರ ಇತ್ತು ಅಂದ್ರೆ, for this particular thing ಅವನ್ನ ನಾನು ಮಿನಿಮೈಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ, ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. So 1 0 1 0, so ಇಲ್ಲಿ 1 1 0 0 ಬ್ಯಾಕ್ ಟು ಬ್ಯಾಕ್ ನಾನು 2 ones ನ ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ. ಹಾಗಾಗಿಲ್ಲ, ನನಗೆ ಬರೀ ಒಂದೇ ಬೇಕು ಅಂದಾಗ ಸ್ವಲ್ಪ ಇಲ್ಲಿ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. So 1 odd, next is, so 1 ಬಂದಾಗ odd ಹಾಗೆ ಉಳಿಯುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 0 ಬಂದಾಗ ಇದು odd ಅಷ್ಟೇ ಉಳಿಯುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ 1 ಬಂದಾಗ ಇದು even ಹಾಗೆ ಉಳಿಯುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 0 ಬಂದಾಗ ಇದು even ಮಾತ್ರ ಉಳಿಯುತ್ತೆ, ರೈಟ್? ಸೊ ಆ ಕಂಡೀಷನ್ ಮೇಲೆ ನಾನು ವೇರಿಯೇಷನ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ, right? So it is associated with the output. So for this particular thing, how it works anta nanu ಒಂದು finite state transducer which is called as Mealy Machine adna ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡಿ. So Q0 upon 1 1 it is even, Q1 upon 1, so then it becomes 2 number of ones. Sorry, this is odd, this is even, this is even. So 0 number of zeros andre, without any input 0 number of zeros andre adana even anta, right? So 1 number of zeros anta andre adu movement illa agirutte. So 0 odd, this is 0, this is odd, so odd input 0 and 1. This is your Mealy Machine. So now we need to define your Mealy Machine. So idralli yavadu, So definitions ಬರೀತಾ ಹೋಗ್ತೀನಿ. So this is first write a DFA, analyze what happens, take two strings, then minimize your particular transducer to your perfect transducer. So ಈ ತರ ಬರೆದಾಗ ಇಲ್ಲಿ first define ಆಗೋದು k, finite number of states is q0, q1. Next is alphabet set. So alphabet set is 0 and 1. Next is transition function. You need to draw a transition table here. So transition table is forever. Transition table will write. So this is sigma to k to k. Next is start state. So accepting state, both q1, q0 and q1 both will be accepted. So even idago accept ಆಗಬೇಕು, odd idago accept ಆಗಬೇಕು. Starting state q0. Next output symbols. So output symbols ನಾನು define ಮಾಡಿದ್ದೆ ಯಾವ symbol ಅಲ್ಲಿ, using this symbol. So output symbols ಯಾವ್ಯಾವುದು, even ಮತ್ತೆ odd, right? So output function lambda is given with k into alphabet set to lambda, right? So transition table first ಬರೆಯೋಣ, next ಆಮೇಲೆ output table ಬರೆಯೋಣ. So transition table, so transition function. So here I got input symbols 0 and 1, q0, q1 start state, both are final states. So q0 on 0 remains in a q0. So q0 on 1 moves on to q1. q1 on 0 remains in a q1, and this moves on to q0. So this is transition table. Next I need to write even the output table. So transition function ige transition table, output function ige output table ಬರೆಯಬೇಕು. So output table na ಹೆಂಗೆ represent ಮಾಡಬೇಕಾ, right? So this is represented using lambda function. So again it is 0 1, this is q0, this is q1, and here again as usual representation of a start state aste, because representation of output illa agutte. q0 on 1 0, q0 on 1 0 it is even, on 0 even. So q0 on 1 it is odd, right? q1 on 0 it's odd, q1 on 1 is on to even. So this completes your Mealy machine. This completes your Mealy machine. So ಈ ತರ ಅನಲೈಸ್ ಮಾಡಿ ನಾವು ಅರ್ಥ ಮಾಡಿಕೊಂಡು ಈ Mealy machine ನ ಡ್ರಾ ಮಾಡಬೇಕು. So ಇದೇ ವೇರಿಯೇಷನ್ ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡಬೇಕಂತ ಏನಿಲ್ಲ, you can analyze. So this Mealy machine can be designed with the different variations also. Clear with this? Yes, getting? So it's getting blurred. Yes, now I'll give few problems on this Mealy machine. Try to solve on your own. construct a Mealy machine which accepts strings of A's and B's A's and B's and count the number of times the pattern AB is present. First question. Second question. Again, construct a Mealy machine that accepts a binary strings and produce its equivalent one's complement. Okay, try to solve these two problems. Okay, next the Mealy machine we will discuss in the next class. Thank you.